Good afternoon, everybody, and welcome to a new episode of Data Trend series. And in this series, we are doing now machine learning. So, the last episode was about multilinear regression and polynomial regression, how to fit it. And we saw a sample code which you can use it for your day-to-day actions, or you can use it like a one time to get some quick results out of it. But then you have to be very intelligent enough to do a model fit, get the rho square value good enough, so that that the new set of data which you will apply the model, it is giving good results, and your management team or your end users are getting benefited out of it, and they have trust on it, because everything depends on the trust. Remember that. It's not that just run a program and get a garbage out based on a good data set. It's not like that. Okay. Before applying machine learning, a quick recap. We already have read or gone through this slide before. Well, the data set, you just cannot randomly jump and apply Python code and get the result out of it. You have to first investigate the data, whether there is variance or not, whether there is correlation or not, whether there is anomaly or not. You have to remove the anomalies. For example, if Mr. Somyajit Parida, that is my name, was dealing with or getting a salary of €1, €1, €1 each month, but then suddenly it jumps to €10,000 in 1 month, and it goes back to €1 in the next month, then yeah, that's an anomaly, that's an outlier, and you can check or detect the anomalies through plotting it or through classifying it. There are different techniques. I will leave it to you guys to further investigate on that. If there is linearity, then it is good. You have to consider that independent variable in your configuration. But if there is high covariance, then that variable is redundant, and you don't need that variable, because it is unnecessarily will affect the coefficient values in the linear regression. Enough. Apply descriptive statistics, and you can understand what the data is, and you can know the only reason why we apply this descriptive statistics or do a research on this data set, because we want to know which elements or which columns or which variables to consider for creating the model, whether it is linear or whether it is non-linear. Okay, machine learnings are divided into two types, that is supervised and unsupervised. I will not go into the detail. Classific or types of supervised algorithms are like this: regression, and in the last session I covered multiple linear and polynomial. Check out the video, the previous video. Go to the data trend playlist and you can see it there. Today we are going to cover decision tree. Yay! Well, decision tree sounds little bit complicated. Okay, how can we code it and what we can do? But no. It's very easy. Decision tree, what it does, it classifies the data. Suppose you have a data set of population, their age, then their salary. Suppose a small data set. Then this is the total data set. It will divide into population which are greater than 60 and less than 60 based on salary. It's like classifying the data into branches. Then you can know which data component or which data set belongs to which group. Excuse me. It's also a way of, I think you already heard the concept of small and wide data. So small, it divides the data set into small data sets, and that's good. You know which, how many type of groups and categories are there. Well, to build a decision tree, we will be using Python now, and in sklearn, there is a ready-made. It's a ready-made library for all the machine learning algorithms, for multiple linear and polynomial to fit the model. We also used sklearn, and for decision tree, we are also going to use sklearn. In the decision tree, there are three components. One is the decision node, the top one, or this one also. Then we have the branch nodes, or the leaf nodes, which are these leaf nodes like this ln, and we have the branch, and these lines are the branch. One decision node. Here I have three decision node and three leaf nodes. Please dive into the detail how, because if I have spent and explaining in detail, then the video will be long and you will get bored. Okay, how the decision tree works? It is based on a attribute selection measure. ASM is the core of the classification, and ASM, the attribute selection measures, are like information gain techniques, and information is gained based on Gini index and entropy. Entropy is like, for example, if you have a data set, and in that data set you have population data set, then the salary component, then uh, rich and poor. Suppose that there are two labels, rich or poor. Suppose, let's say this data set you have. Then if a decision node creates two leaf nodes, and in one leaf node there is both rich and poor labels, then this leaf node is impure. But if this leaf node has only rich, and if this leaf node has only poor data sets or small subsets of data, then these are like high, means these are entropy value varies from 0 to 1, and 1 means high entropy and 0 means low entropy. So these will be like 0.1 or 0.2. This will be like 0.8 or 0. I mean, there is high impurity in the leaf nodes. So entropy measures the purity, and Gini index is based on data group inequality. I mean, it is also one of the index, and I exactly don't know the details of Gini index, but it's a way of, means these two information or the measures of these two makes the information gain technique KPI, and that in turn acts as an attribute selection measure to classify the data sets. Okay, enough of the theory. Now we will go back to the code. It's a in sklearn library. It's a ready-made code, and it uses only 2 or 3 lines of syntax to get the results quickly. Okay, so this is what I have. I am using pandas, and I'm using sklearn and the decision tree classifier. Uh, this is the element in the sklearn that I am using to get the classification, and then I'm using matplotlib to plot it, and some of the other to calculate some of the measures or KPIs. I'm using some other things there. Okay, so the data set has, it's a data set of a hospital where the people. Let me show you the data set first, then I think it will be easier. It takes a little bit time, guys. So the columns in the data set are that whether whether what is the level of pregnancy, what is the level of glucose, BP. It's a random data set that I created. So don't go into the details of whether it's right. I just created some random values there for these columns, and the person's age is this one, and label 1 and 0 is like whether the person is fit or not fit. Just a random thing that I created. Don't go into the details. And this is the level of each each measure. Okay, so this is the a person's health kind of health report, and then I'm using these columns for the model fit or creating the model. So the X are the selected columns or the features. Then the target variable is this level, whether the person is healthy or not. So then I classified, means I divided the data into 60 40%. 40% the test size, and 60% is the data that I will use for creating the model. Okay, then the decision tree classifier based on the criterion of entropy, that is the Gini index and the entropy that I said earlier. And the max depth is like this is a 2-level depth, and here I have 4-level depth there. Means I don't want to make a big, if I don't give a limit here, then the result that you will see, it's a big tree, which it doesn't make sense to have those kind of big tree, and it will not be able to give me good insights. So I've just taken that, okay, the maximum depth should be 4, and then I have my model fit, then I am predicting, and then I am printing the accuracy as well as plotting the decision tree. And I am testing this, on the test data set. I am predicting what the results. Then I can compare it with the actual data and the predicted data. But that one we are not going to do it now. Maybe I will leave it to you guys. This code will be available in GitHub, and you can directly download and do whatever you want. Okay, so let's run this code, and we will see. Yeah, so this is first level, this is the second level, this is the third level, and this is the fourth level. So 1, 2, 3, and 4. So the maximum depth is 4. So we got 4 level. The data got classified into 4 levels. Let's see. Let's take for 5 levels and see what it shows. Accuracy, and you have to be testing it based on the depth. The accuracy changes, and you can test it. It's a trial and error. There is no like a definite definition of how much the depth should be. Okay, the depth remains the same. So you can see here the accuracy was almost the same, and here you see the age less than 58.5, and age here, this is age more than 58.5. So then insulin less than 96.5, insulin more than 96.5, sample data set is 5, and insulin less than 92.5, sample data set is 175. Then age less than equal to 57.5, so age greater than 58.5 was 12 data sets. Age less than 57.5 is, so this is how the data gets divided and the decision tree is formed. So you can know what it gives us insights, what the data set contains or constituents. So that is about all about decision tree. This is a yes, and this is a no, or greater less than equal to yes, and this is a no. And these are the leaf nodes, we can say it. Okay, so this is what I wanted to share of decision tree. Is the code, main thing is understanding the code and getting a good accuracy of the values. So I can check the prediction with the real data set, and I can know what's happening. Okay, this is what I want. Maybe the accuracy is bad because I have taken a random data set. Means the CSV file that I am using it here. I use the rand command in the CSV file to generate the data set rather than taking a real time data set or real data set. So please excuse me for that, but that is for you to practice on. This is what I wanted to share, and please like and subscribe, guys, and this makes me really happy to further make this kind of videos and share. This also makes me in touch with Python, and it improves my coding skill. And the thing is that, guys, you don't have to learn it by heart. Just keep this sample codes with you. Whenever there is a requirement by the end user, you can just take this out, make some small corrections, done then. Okay, have a nice day, guys, and we'll see each other in the next video. Till then, bye bye.